Okay, first of all, let's talk about this inheritance. I just would like to introduce, let me just run my small application that will serve as my board, and let me display this on your screens, and let me find a way to silence that phone and silence mine too. Thank you. And now, when we have inheritance, we've seen that in Java we have what we call single inheritance. Why? Because every class inherits from only one class as a maximum. As a minimum, well, technically we said none, but by default in Java it's one and one only, right? Every class, if it's not inheriting from any other class, is going to be inheriting from object. So everybody is inheriting from object. Either you inherit from a class that inherits from object or whatever. So you inherit from object all the time. But there are some situations where it makes sense to have more than one superclass for a subclass. You would like to have, for example, a class A, but that can take some of the variables from B and C. So this multiple inheritance is not something that doesn't make sense. For example, let's talk about some kind of a vehicle that is amphibious vehicles. It's a vehicle that can go on land and on water. So it will take some characteristics from the land-based vehicles and those that are water-based vehicles. So this is something that actually is in the real world. It's not something that we'd like to create, to come up with. However, the problem when we have this multiple inheritance, and I'll take your question later, is that what if you're inheriting the same method, let's say get A or info or whatever, I'm going to be, let's say each one of here has a method called info, and this here has a method also that's called info. Now both of them are public or whatever. I'm going to be inheriting both of them. Now the problem, a.info, which one? So now I'm inheriting both of them from A and B and C, so which one is going to be called? So this is a problem. So in Java they said, okay, we don't allow to have multiple inheritance. We have single inheritance. That's what is going to be happening. But we're going to be doing something that will allow us to simulate or get close to this kind of situation when we have one class that can have some kind of multiple inheritance, but not exactly multiple inheritance. So that's the role where the interfaces comes into action. Now you have a question.
Yeah, in the beginning you told us you cannot inherit.
Yes.
To
in Java,
yeah.
Yes. So in Java, this is one. No, you can't. You still can't. You still cannot inherit from two classes. And there's no way that you can inherit from two classes. But there's a way to get closer to that situation without inheriting from both classes. And let me show you how. And this is the interface. Now, if we would like to be doing something similar, we are not going to be inheriting from a class. We're going to be inheriting from some kind of a special class, which is called the interface. Now, that interface is a very special class because, first of all, it's not a class. And it does not have variables, but it can have constants, final variables. And it does not have methods. What kind of class is that? But it can have abstract methods. It can only have abstract methods. Which means if you have an interface, you can say that this interface has some abstract methods, abstract method 1 and abstract method 2. Now, if you have abstract method 1 and abstract method 2, then you have something. These are abstract, which means they don't have any code. So there's no confusion when you're going to be inheriting, even if somebody has another method. If you inherit from, class B and it has A1 as well. Now this is a concrete class as opposed to an abstract class. This class A1 has a method A1 that is defined. It has some code. Now if I'm having both of them, well, I'm going to have one that has some code and the other one that doesn't. If I would like to change it, then I can maybe define my own, and this is called also overriding, and there's nothing new there. but there's the possibility that you can organize your code to have some kind of relationship between different classes and interfaces, and this way you can have some kind of multiple inheritance. That's not really easy to have a look at it unless we go with it.
Class B was an abstract.
Now class B is abstract.
Yes, and we have interface.
And you have an interface. That's even easier because abstract means this is going to be either an abstract or not. So if it's abstract, you're going to be, let's say the worst case scenario is both of these A1 are abstract. Both of these two methods are abstract. When both of them, when we say that when we inherit from an abstract method, when we inherit from an abstract class, a method that is abstract, there's one condition that either I become abstract or I implement that method. So now I have two reasons why to implement that method. I have to implement that method because it's coming from here, and this one is abstract. And I have the same method A1 that needs to be implemented. So both of them are asking me, you have to implement A1 or become abstract. So that's the thing. So it doesn't conflict with what we've seen before. Yes, Khalid. Back. Just raise your voice. No, forget about the address. I just trying to simplify things here. I will go into the code later, but just the idea is, now if you have an abstract method coming from a class that you inherit, you have to implement it. That's the order. Now if inside of an interface there are abstract methods, the same order is I have to implement them or become abstract. But I have to implement them or become abstract. That's the same thing. So the same logic that we've seen before, we're going to be seeing it again, except now we are going to learn how to use some kind of a special class that is called interface, that does not have variables, only constants, and it doesn't have methods. If it does, all their methods are abstract. There is no one, you cannot define a method inside that interface. Yes, your question. So that's what we're going to be seeing. And there's some examples that are here. Like, let's have a look at this one. Now this here is some kind of an example of an interface. Now interface doesn't have variables. If it needs to have constants, it can, but it cannot have variables. And then these are all abstract methods, which means now this movable is an interface, and actually as some kind of a standard way how to name interfaces, they're named and in that able thing, movable, suitable. Yeah, that's nice. Suitable, I don't know what's it's a good name for an interface, but if you have, for example, that you would like to have something that moves something, you're going to make it movable. I'm trying to think about another example, and unfortunately I'm blacking out. There's other interfaces that is clickable. That's another one. If you click on something, for example, you double click or single click, or if you keep pressed, or you removed your finger from the button. So these are different names for the interfaces. The idea is that they finish with able. It doesn't mean that you have to, but it's better because you need to just represent it in a way that is going to be uniform with the rest of the Java classes. Now, if I have something like this now, what I'm saying is that this class is inheriting from this interface. But actually we don't say that. We don't say that we inherit from an interface. We just, actually basically we inherit, but we don't call it that way because we reserve inheritance to classes. We inherit from a class. So what do we call an interface? We implement an interface. We inherit from a class and we implement an interface. Now this is the symbol of the inheritance though, but notice that it's kind of dashed. This is because it's not inheritance, but it's implementation. Which means now if this interface is the superclass, it's not that, it's not a class, it's an interface. So if it's the base class of this movable, it means that movable has to implement all these methods because they're all abstract, or this should become abstract. Now I would like to show you some other thing, which is this symbol here, because this is the first time that we've seen it. What does this mean?
Have a subclass.
No, there's no subclass, because subclass is the triangle. That's what we've seen. This is composition or aggregation, and there's different. I don't want to get into the distinction between the two, but the idea is that, see this movable point? This is a class that is used by this class. Check here. This is X. This tilde here, this is another thing. This is called, this is the same thing to represent package. Because the protected, we agreed, that's the hash code, hash key, or the pound key, I don't know how they call it. And now look at these. This is X that is int, X speed is int, and then radius that is private and it's int, and center that is movable point. So this just tells you, actually this symbol tells you that this class movable point is using the class movable point. This class movable circle, sorry, is using the class movable point, because I'm using a variable from that type. So that's why I'm using it. That's what it means. That's it. So this is a representation. I'm going to do a simple one. I'm just going to get into a very simple exercise when we're going to be working with the implementing interfaces. So we're going to get to that later, but for now let's just do some kind very simple. I'm going to go back to this, create a new project, and call it intro interface. Okay, what did I do? Back. I'm in C++. No, I don't want to be in C++. I'm in Java now, and I said intro interface. Okay. So this is going to create this project thing, and then the main. I'm going to ignore the main for now, and I'm going to create a new. You see now? Before it's like we were not seeing it, but it was there. It's a Java interface. Now I'm going to create a new interface. Just give it a name. What was the name? That's usable. Usable. I like it. Usable. The interface is called usable. So first of all, we don't call it a class because it's an interface. And then in that interface, as we said, you cannot just declare some variables there. You can't. But if you want to make them final and put some values in them, it's permissible. You remember the final thing? A variable is final because it cannot change. And if we make it final, that means it cannot change. So now this becomes a constant. Okay, now I don't want to have that. Let's say I'm going to have this interface usable to have a method called method1. Just to, of course, this is not a way how to define a method that is abstract. I need to mention abstract, but it's not. That's not the big problem. Actually, the big problem is not this one. If I do something like this, if I say this is a method, it has a missing component, which is the return type. I need to return something. Either it's void or int, or this needs to return something. So let's make it void. Now notice that I did not put abstract, but if you put it, you just type in more words, because we said that inside of an interface you cannot have anything else but abstract. So you would like to type, but even if you don't type, it's abstract. So this is an abstract method, and I can have another one. That's good. Okay, now if I don't put anything, this means what? That's a good question. So I pressed some button somewhere, and then I'm going to enjoy this icon for some time. I think there's some kind of a shortcut that is close to this Control C, and I'm pressing it and I cannot get rid of it.
Can a class implement more one interface?
Exactly, yes. A class can implement more than one interface. And a class can inherit from a class and implement an interface. An interface can inherit from another interface.
Cannot be implemented.
Because it can't implement, because implement means it has to put some code, and it cannot implement an interface. An interface cannot implement an interface, but it can extend an interface. Yes.
So why we use the base classes? Why we just rely on interfaces?
What do you mean by rely on interfaces? Because you cannot rely on something that you don't put code on it. You're not putting any code in the interface.
The interface and the classes that put code.
Well, first of all, you said rely on an interface instead. Instead of what? The classes?
Base class. No, I mean if I want to inherit something,
Okay.
instead of put classes, just put interfaces.
What?
What's the difference between interface and?
Okay, that's maybe the better question. What is the difference between an interface and a class? A class, well, it has some code inside of it, because it has some variables and methods. Generally speaking, we're not talking about some special cases like abstract classes, etc. But the interface is some kind of it's more of a concept, because it does not have any code, and you adapt that concept based on your needs. For example, this movable that we've seen, you can move up, move down, right and left, and you can apply this concept of move up, down, right, left to a triangle or to a circle or to any shape, basically. But the idea is that if you would like to move a circle, it's not the same that if you like to move a triangle. The action is different. So if you're implementing movable from a circle point of view, you're going to put the code. What is the code to move up? If you're implementing movable from what is it, square, or so it's going to be different. So that's the but the concept is the same. They are moving up, they are moving down, on right and left, but the way they move is different, and is going to be implemented by each one of those different ones. And I'm going to go back to this example, inshallah, just immediately after this one. I just would like to get into this one, if I can find it again, which is interface. Yes, you had a question? Good question. Looks like I've just heard that question before. But this question, what the difference between a class and an interface is that the class is more concrete, it has more code in it. Just to simplify that. And the interface is like a concept, more something general. You don't have the details of it. So interface, general, class, more detailed, more specific. Yes. Interfaces with inheritance, yes. Well, let me do that. I'm going to talk about the inheritance thing. First of all, I just prepared an interface usable that has two methods. First of all, I did not put any public, private, protected, so that means package, right? No, that's another specialty of the interface. It's public. Notice here, you remember every time with NetBeans, actually, when you have something that is public, I'm going to see it. For example, I'm going to create a class. NetBeans represent things in, let me create a class. I'm going to call it my class, whatever, because I lack the any imagination for now. Let me just put public method void m1. Now m1 is a problem because I'm inside of a class. I just defined one method and I did not put the code. So that means this should be abstract. So now this is confusing. So either you're missing the body of this method and you have to put, or you miss the keyword abstract. So what do you want to do? That's what it's trying to do. Make it abstract? No, I don't want to make it abstract. I'm going to put some code. Yes, we did it. Now I did this just to show you this M1. You see the symbol of it? If it was, I'm going to create another one so you can get the picture. protected. This is, of course, should be another name. You see the symbol of it? And what if it's private? I think you know how private works. And what if it's package? By package, I can just remove this and this, make it private, so you can see them all. Now this is the package, this is the private, and this is the protected and the public. Now if I go back to this method, I did not put anything, but it's like public. That means if I put public, there's nothing that is going to change. If I make it private, it's kind of weird. Private interface aren't supposed to be in. What is a private interface though? Because you have a private abstract method, which means that your subclass should implement it, but your subclass does not have access to private. So this is an abomination. This is something that should never have been created. So this doesn't make sense. Yes.
Isn't it please help us without putting an abstract? Like if we do it in another.
No. This is not about NetBeans. This is just Java. So if you do this like this in another IDE, it's going to be understood the same way. This is a public abstract method. Now the thing that you can do something like protected. No, because modify protect is not allowed. The only thing that is allowed inside of an interface is that the method should be an abstract public method. So there's no other options. All your methods here are public. So if you want to type it, that's fine, you can type it, but you don't really need it. Now these are two different things, this usable and this my class here. Now if I'd like to link them, I'm not extending an interface. That's not possible, because this no interface is expected here. When you put extends, this is for other things than interfaces, classes actually. But if you'd like to say that, this class, my class, you would like to be able to implement all things from that interface, I'm going to say implements. Now as soon as I do this, now this becomes a problem, because it tells me my class is not abstract and does not override the abstract methods and method 2 in usable. Basic actually, if the fix is to implement all abstract methods or become abstract myself. So either become abstract, or if I would like to do something about it, I need to implement all the methods, which means I have method 1 and I need to put the code. And this is where it's interesting, because this can accept to have, for example, I can implement different methods coming from different classes and from different interfaces. And I can simulate as if I'm inheriting, but actually I'm not. There's no multiple inheritance. It's single inheritance all the time. But it allows me to organize my code to be I need to implement something and extend something else, etc. So that's the idea, yes.
Can a class have the same name of an interface?
Sorry?
Can a class have the same name of an interface?
Can a class have the same name as the interface? Yes, but not within the same package. Which means, now this package here does have a class called my class, and this one has usable. Now, if I'd like to, I'll just create a new package. In that new package, called new package, I'm going to create a new class, and I'm going to call it usable. Nothing can prevent me from doing so. But it's not, a good practice, because this able thing is normally reserved for interfaces, but you can name it whatever you want. Of course, you cannot have two same file names within the same package. That's another issue. But I think I answered your question. It's possible to have the same name, but it should not be in the same package. Yes, another question there?
How to implement the
What is?
how to implement
How to implement?
and then also extend from that.
Okay, I'm going to do that, inshallah. But just give me a minute. Yes, your question? That's the same question. Okay. Private in method 1? You mean this? Sorry, method 1. This one? No, I can't. Yeah, because if I'm overriding, I can change this, but to open it more, not to close it. And because it's already public, I cannot open it more than public. Which variables? These are methods. No, we did not override them. These are just I just showed you different how they are presented. So the basic concept is this: when you have an interface, you implement it. You don't extend it. And the idea, you can have extending in a class and implementing an interface. And I'm going to do something similar to this. Maybe I'm going to probably to allow you to do that, to adapt one of these things to do something similar. Let me just let me do something about it. Now, but let's keep this just in case we need it later. So now, my point of all this is just to introduce you to the syntax on how to define an interface. And we've seen that you define interface by using this interface instead of the class. And then inside that interface, first of all, before the inside, the name, it's suitable, it's better if you give it a name that ends with able. And then inside this interface, what you can find, two things mainly: constants and public abstract methods. That's all you can find. Yes.
Can you show us
That's what I mean. Just a variable that you cannot change. Override what? What do you mean by override the constant? Now, if I do something like this, okay, maybe I understand what you're trying to say. You're trying to say that I'm inheriting now the A, because if I have this constant means now, sorry, if I'm here, that means inside now this class, my class, I'm able to have access to this constant here. Now, if I'm going to create a new instance from my class, say C equal new my class. Okay. Now this C dot, I'm going to see everything that is M1, M2, etc. Where is the? I'm not seeing the. I'm looking for this. Let me just put it here. I'm looking for this one. No, it's not about the override, because these are something more complicated that I don't want to talk about. These are static. See this symbol here? When you have a variable like that, and actually it means it's static. And by static, it means now I can use it just with the class name. This, you remember this talk about static? This is a long time ago in Java 1, basically the end last week of Java 1 probably. Anyways, so let's just not focus about that for now. Let's talk about it later. But if you declare it, you can actually you can access it, but it's a static variable. Yes.
How can I call it
What you can call what?
the variable here? On the,
Let's forget about the variable now. This is a constant.
the constant.
Yes.
You can call it to a class.
I don't want to talk about it now. I don't want to talk about this variable. I just would like to focus about the other things. I'm going to talk about it later. But first of all, let's just get the most important part, and then these small details, I feel that are going to confuse you more for now. So let's just put them aside. We're going to talk about them later, inshallah. But for now, let's just focus on just this thing. Now, I'd like to show you that this C dot is going to show me the ones that are available from within the class and those that I'm implementing from the interface. but they're all belonging to, even though I'm implementing them from the interface, this method 1 and method 2, these are not the one from the interface because I override them. Yeah. So I put the code of those methods. So these are kind of, now these interfaces, they just do what? They just force the classes who implements them to implement some specific names of methods. That's what it does. That's what they do. So an interface is going to force a class just to implement some set of methods. So why would you do that? So this is some kind of organizational stuff. It's just to organize the code. I would just would like to be able to, all of my, let's say, to get back to this example, all of my movable objects, movable circle, movable square, movable triangle, all of them, they need to move up, down, right, left. Well, I'm going to make them, all of them movable by make them all implementing this interface. I'm making sure that every one of these is having to move up, move right, move left, move down. If I don't do that, I may forget to do some move up in one of those. But if I make them all implement an interface that has all these methods, everyone has to have all these 4 methods implemented. So it's more organizational because it allows all the subclasses, not subclasses, all the classes implementing the interface to have these methods. So you make sure that your code is consistent. That's one of the good things. And I'm going to be inheriting and then doing some kind of things like that. So I'm just going to be extending this to have you, seeing I'm extending a class and implementing an interface. And let's do that. So I'm going to stop this, create a new project. I'm going to call movable. Okay, movable, not movable, let's say. And let's close everything, close all. And I'm going to create a new interface. Notice the symbol of interface is different. I'm going to call it movable. Is it the name? Movable. And I made a mistake now because I have a problem. It's already called movable. That was not the best. You know what? I'm going just to delete this because I'm just. I would have done that, but I just would like to do it from the beginning. I'm going to make it movable app. So by doing so, I'm just making sure that this is going to, the app is going to where I'm going to be having the main. And now if I create a new interface and call it movable, it's not going to be a problem. I could have also did this refactoring thing, but I was maybe too quick on deleting. Notice this symbol here are different, so you can see in the list of your files that this is some kind of different from this one. This is an interface, this is a class. And also here you see the symbol of this class is different. If you see, this is the symbol of a class and this is the symbol of an interface. So now this interface, it does not have anything except move up, that is void, down, left, right. That's what I'm going to do. So I'm going to have move up. Oh yes, I forgot the void. And copy and paste, up, down, right, left. Now what I'm saying is that anyone who is going to be implementing this method has to come up with some code for all these methods. So now what I'm going to create, I'm going to do something similar to what we did before. Remember the class shape? So I'm going to have the shape that's going to be having this private color. Let's call it color with a string, just not to bother with other data types. And is field thing, I'm not going to go with that. Just do something simple. I'm going to insert the constructor that initializes the color. That's the only one we have. Maybe let's insert the one that does not insert anything. Just to have this the no argument, default no argument constructor. And in that case, the color is going to be blue. Let's see. So by default, it's going to be blue. Oh, let's make it white, just because I like white. Now, I need to have setters and getters. Let's just get them. So just for convenience, and encapsulate the field. It's already private. So anyways, and the last thing. Let me add the toString. So that is going to display the color. So this is a shape with this color. Fine. Now, why did I do that? Because I want you to see how I can. I'm going to be having one of these to be inheriting from the different classes, a class and an interface. So I'm going to do something similar to this. So, but let's just go back to this here, and I'm going to create a new class. That is going to be a circle. Okay, and this circle is going to be, let's call it a movable circle. So it's going to be, different from that circle that I have, and this one is going to be extending the shape and implements the interface. Now I'm doing two things. I'm inheriting from shape, and I'm also implementing the movable. Now, as soon as I do this, I have a problem, not because of the first part, but because of this. Now, if I implement, I need to implement. So I'm going to implement all abstract methods, and you're going to see just put some code that is going to just throw exceptions. But anyways, I have some code to do something. I'm going to put some code in that anyways, in a way, but in order for me to be able to do that, I will just make something simple, just for fun. Now I'm inheriting from shape. I would like to have some kind of a class called, but I would like to have, let's make it simple without the class. Let's put int x and int y. What is this x and y? These are the coordinates of the center of the circle, because I just need the coordinates of the center of the circle plus, or maybe make it double, plus the radius, and I can draw any circle, right? I'm going to get the constructors that are going to be initializing everything along with the with the thing, and maybe have another one that just initializes let's just call them nothing. I don't know, just for convenience, even though this is not really convenience, but just anyways. Now I have this constructor that initializes the center, the position of the center, plus the radius, and then I get the color. Now yes, question? Well, yeah, let's put getters and setters. It doesn't hurt, because you can generate them all. I'm going to generate them all, just making everything encapsulated and everything. So I'm just going to generate them all. I don't mind for that. And let me do something. Let me have the toString and include everything, and also from the color. Let's just say color. Can I do this? I cannot do this because in shape it's private. So if I want to do that, what should I do? I just in the shape make it protected. It's better than public, because I just would like it to be inherited. Now, if public means everybody can do whatever they want, but if I just would like to insist on making it private, what should I do here? Because there's a getter, use the getter. I have get color. Now just put a space and okay. Now let me give you something that makes sense out of these move up, move down, because as of now these are just empty methods. How can I make sense? Now if imagine now, let's just erase everything. Control Z is a good friend. Now imagine that this is my circle. If I move up the circle, what should change? the x does not change, but the y is going to be changing because I'm moving up. So I'm going to increase what? Well, if I'm increasing, means the y should be increased by, I don't know, let's say 10. I can specify what increment I'm moving up to. Am I increase by 1? It's up to you. I don't know. I don't mind. So I'm just increasing by 1. Now this do what it will move the things up. Move down. So this y is going to be minus 1. And right, if I move right, so the x now is going to be plus 1. And if I'm moving left, the x is minus 1. So now this becomes a kind of object that I can move right, left, up and down. Well, let's try that and see how this works. Let's have some kind of I have a movable circle. This is the circle, equal new movable circle, and then I need to instantiate with everything. So this is the radius. Well, let's start at 0, 0. No, sorry, the position, the x0, y0, and then the radius is 10, and the color is okay, white. Now, if I do this circle dot toString, I mean, I need to display it basically. So let's just display that. I'm going to display now the toString. It's going to show me that this is a circle. It is a movable circle, which is white, and the position is 0, 0, and the radius is 10. Now, what happens if the circle, I'm just moving up, move up, and then circle dot move, well, I'm not going to see anything, left. I'm moving up, and I'm moving left. So I'm going up and left. So y is going to become 1, and the x minus 1, because I'm going that side. It was 0, it will be minus 1, because at the end we started 0, 0. Now if I run this thing, I'm going to see minus 1 in the x and 1 in the y. Just because I did this. If I just do just the move up thing without the move left, this x did not change, but it went up. So that's a very simple class that allows you to see that I'm inheriting from another class shape, and also I'm implementing something from an interface. And just to have different, I mean, what I can do, just, and I'll take your question, I'm going to create I can create another class, the rectangle, remember that rectangle, and I can also make it extends the shape and implements the movable. And of course, I just need to also implement everything, etc. What I can also do is, instead of doing this all the time, I'm going to do something better. Now, where is this movable circle? Instead of having this like that, I can just make them extend the shape. Instead of me typing implements also, just make it in the shape. Movable. Movable, I meant. But it's not abstract. I need to implement them, but I would like to make it abstract actually, because I don't want to implement from shapes directly. Now I make this abstract, which means there are some abstract methods that my subclasses will have to implement. And these are not coming from me, they're coming from my interface that I'm implementing. Now, this is, even if I'm extending shape, it tells me we have to implement all abstract methods, which are this move up, move down, move right and left. Which basically, actually, this will make more sense if I rename this, but to make it a movable shape. Now, this movable shape, because I'm inheriting from movable shape, that means I need to implement all the methods. And the main advantage is, if I'm having a rectangle, I'm making sure that the rectangle has move up, move down, move right, move left. Anything will have those methods. So to organize my code, this will help me not forget, for example, having to have one of these methods, especially when you have a lot of these shapes. So you had a question.
Can I put move up multiple times?
You can call it, yeah. You can call it, yes. You can You can do something like this. Okay, just count. I don't know. I'm just going to trust. Oh, cancel. I have a problem here. Yeah, because of this thing. Let me just make it abstract, just to get rid of the problem, and just run, so I can run the code. Now I did this 2, 4, 5 times. I'm expecting that this becomes 5. Yeah, because it keeps increasing. Yes. Yes. When you create an abstract class? No, it's up to you. If you create if you have an abstract class, it's up to you if you would like to have a variable or not. It's up to you. But when you make a class abstract, what you want is that nobody can instantiate from that abstract class. That's what you want. And if somebody is inheriting from that abstract class, and that abstract class has some kind of methods that are abstract, then it has to be implemented. Yes, questions? Okay, if you don't have any questions, I would like you to try that. So let me free you so you can do those things and get to